Hello, and welcome to the Cloud Multiplier, your show for all things distributed cloud. I am your host slash co-host, Gurney Buchanan. I am here, as always, with my co-host, Joydeep, and we are actually joined by the wonderful Multicluster search team from Red Hat. So these are the three folks behind a lot of the Multicluster search. They can call out anyone else from the team because there are a few of them. But it is an absolute pleasure to have you guys here today. As always, we're a show for people, made by people. So we're going to go around the room. We'll do some introductions, talk a little bit about our background. I will say to everyone on stream, I'm hoping to change out the board games in the background next week. That'll hopefully become a regular thing. So 2 weeks from now, maybe some different board games will show up. So there's my little hobby for the week. Joydeep, got any hobbies for us this week? We're going to keep changing this up until something sticks.
No, not any hobbies, Gurney. The last 2 weeks were rather heads down. As I told you earlier, this was the first time we actually chatted in 2 weeks' time.
Yeah, we made it a whole 2 weeks. We did release a product in there. We released a new version in there.
We did release that's probably one of the reasons, right? And the only other thing I can report on, it's been awfully hot here at South Bay in LA area. And where I live, we had to turn on the AC for a few days every hour. I mean, for a few hours, for a couple of days in the last 2 weeks. That says it all.
That is, for us North Carolinians, we're kind of finally down into the 80s, but the problem is the humidity is also in the 80%. So you step outside and you're like, oh, that's a nice breeze. And then you just kind of start sweating and it's not great.
But it feels much better than what we had before, the upper 90s. So.
And the same humidity at that. That's a good. Jorge, we both live in the same place. Let's go ahead and tell us a little bit about yourself, Jorge.
Myself, I am Jorge Padilla. I'm the team lead for the search feature. My hobbies, I recently got a 1-year-old baby, so she consumes all my time. It's all watching Cocomelon and baby shows. I'm going to the park with her. She's walking.
Parent is not a bad hobby.
Making out into the park. Now that the weather is a little better than what it was a couple of months ago.
That is awesome. We'll keep going around. Let's swing down to Xavier. Tell us a little bit about yourself, Xavier.
Hey, my name is Xavier Dharmaiyan. I work for Search as part of the ACM team. My technical background mostly, analytics. So I do scale analytics for Search. So if you do not see me at working, you can see me at the soccer field, or you can see me at practicing for the half marathon that's coming up in November in downtown Raleigh. So if you are one of them who's running in downtown Raleigh, come say hi to me if you happen to see me in the huge crowd that is running up there.
Oh, wow.
Yeah. Will you be wearing a distinctive shirt or anything so we can pick you out? Rackham merchandise or Red Hat?
Maybe I should run with a Red Hat t-shirt. Maybe I'll run with the Red Hat ACM t-shirt. So
we should sponsor you. Actually, should sponsor.
Yeah, that's a good point. You should sponsor me.
I didn't know, Xavier, you were that serious, because I remember once every now and then you slack and say that, hey, I'm going out for a run. I didn't know that you're into serious preparation. Wow, that's great.
That's amazing. And finally, around to Disaiah, who has a better streaming background setup than I do, and I am jealous. Go ahead and introduce yourself a little, Disaiah.
Yeah, sure thing. So hello, everyone. My name is Disaiah Bennett. I'm one of the engineers on the Search and Observability Squad. So in terms of hobbies, I'm not running like Xavier, and I don't have any kids yet, but I started getting into building PCs. You can't see it here, but off screen is a very beautiful big PC that I'm building, and hopefully I'll get it ready soon. So I'm glad to be here.
Whole loop water cooling?
Yes.
Of course. You got to. Hardline water cooling, though.
Yes.
Oh, gosh. He went all in. That's amazing. Well, we are here with episode 8, so a little bit of background before we get into these wonderful folks to talk about our topic today. We've talked on the show about a variety of things. We have a bunch of, we actually have 3 shows scheduled out from here already. A little bit of background, but talked about Hypershift. We talked about growing your fleet. We've talked about building and automating your fleet with Ansible. We've talked about observing your fleet. We've talked about rolling out upgrades. We've talked about some of the managed services and analytics that can help you run your fleet in a reliable way. And today, I think we're going to be doing one of, honestly, my favorite deep dives. The search folks from the Multicluster search team here are going to talk to us about the Multicluster search component in Rackham and in general, the open source Multicluster search project. They've also been involved in some other open source projects that are really cool. Maybe we'll talk about that a bit. But this is really, for me, a DevOps, SRE, someone who runs some infrastructure and multiple clusters. This is really a dream. So I think, I forget who said they're going to kick us off, but do you want to give us the primer on multi-cluster search?
Sure. So like Gurney said, we have seen before on the show that Rackham helps you to create a fleet of clusters. It's very easy. You go and create 10 clusters, you go and create 1,000 clusters. So after that, how do you manage those clusters? We can go the traditional way, go to CLI into each of the clusters, do your thing there. But no, you're talking about 10 or 1,000 clusters, that's not feasible. Or you don't want to keep all those passwords or switching context and all that. That's where really search comes into play. We collect data from all those clusters. We're monitoring the clusters and bringing data pretty much near real time. Bring all that into our ACM hub cluster, and from there, we provide you ways to search for your resources. Like everything is in one place. You go and search for some conditions. Like for example, you want to see your trading pods. You want to see all the assets that have a specific label. You can see results very quickly across all your clusters. Now it's super fast because we are doing the indexing pretty much continuously in real time. So like you could have automation that goes to the cluster and brings the data, but again, the fact that we collect that beforehand makes it super fast. So goal is that you can access that data not only for problem determination. In the future, we're planning to do more things like analyze that data, analytics on top of it, see how things come flowing into the system, how things change, and we can build on top of it because it's now it's on a database that's more queryable, and we can use that data in many different ways. So yeah, that's the different scenarios. We started definitely with the problem determination part because that's what most SREs are interested on. You have your application deployed in multiple clusters. You want to see one of the clusters start failing. You want to failing, see the assets that are not checking for statuses and all that. And then you want to probably compare against other clusters, see if the problem, if all the clusters are showing the same signature of the problem. You can do that by running some quick search queries and really figure out if it's only one cluster having the problem, all your fleet is hit by the same issue. And then from the Rackham UI, you can even see the logs of the pods, try to do some problem determination from there. We do allow you to edit the YAML resources, which probably you don't want to do in production, but it's like a way to interact with the cluster. You probably want to take that into your GitOps and do the changes there. So search provides you all that.
So you're saying I don't need 9 different tmux windows open with 9 different kube configs to check the status on my production application in US East 1, 2, Central 1, 2, West 1, 2, and then our backup in each region.
Correct.
I can just go one
you're
place.
touching on a very small scale scenario now. Imagine that blowing up to thousands. So.
Yeah, a tmux kind of, I'd say tmux and different kube configs probably don't scale well into the thousands, right?
Yeah, even at 10, you can feel the pain of it.
Yeah. And Jorge, what kind of data do you collect from the clusters?
So more like high-level data. You know, if you imagine if you do OC get pods, you know, like at the least level, everything on the command on the OC CLI, you'll see like the columns at the high level. So that's what we collect, you know, because we want to index small amount of data. We don't want to index everything because then we
Sure.
lose the benefit of the speed. Really, we're building search based on speed and getting the data that you need.
So collect data on a subset of cube resources, basically, customs,
we collect data on every cube resources, including your CRDs.
including CRDs.
Yes. So we
Fantastic.
basically query the Kubernetes system, and we learn all the definitions that are there, and we watch all the resources and bring that in.
So Joydeep, if you are worried that if you are going to expose any of your secrets, don't worry about it. No, you're taking care of it. We will not be picking up everything. We will be picking up only the metadata that is required for the user to search.
Great.
So don't worry about the security there.
Yeah. And can we also configure how much we collect, etc.?
Yes,
I mean,
we definitely. Yeah, good.
Good.
Okay, good.
Good.
Yeah,
Good.
if you
This
were,
sounds-
we
yeah.
can configure what you collect. Now, if you were not interested in certain resources, if you're like worried about just us collecting the name of the secret, which is basically what we collect, you could turn that off and not collect other resources and fine tune the things that you collect.
Mm-hmm.
Those important knobs to have for your InfoSec team to tune a little bit.
Right. Okay, this is interesting. This is very interesting. I'm dying for a demo to show up where you can show Gurney how easy it is, or hopefully.
They've, I think, promised or lean towards my favorite type of demo, which is breaking something live so that they can show me how they figure out how to fix it. So fingers crossed.
Yeah.
Another thing I want to add before we move on to Disaiah's demo, like we also protect the data with RBAC. So like we brought the example of secrets, but also we kind of follow the Kubernetes rules that you have set up there for who your users can see secrets and all that. So we're bringing those rules into our searches. So the user is not seeing anything that they have not been authorized to see on your Kubernetes cluster. So rest assured there's that level of protection as well.
And actually, within the demo that we'll be showing today, Jorge, we actually have some RBAC set up on the cluster. So I'll make sure to show you guys that also. So if we can go ahead and get started, I'll go ahead and share my screen. Let's see. Can you guys see my screen?
Yes.
All right, perfect.
Yep, we can see your screen.
So when you first access ACM, you will be brought to the show you the different features that you can access within the console. But what we want to focus on today is the search feature. Go to the left-hand navigation dropdown and select the search page. Now, one thing that Jorge did mention was problem determination, and search actually provides 3 different templates or suggested search templates for a user to use once they access the search page. And the one that I wanted to focus on today was actually the unhealthy pods. And this will show our users a quick insights into the health of any pods that have a unhealthy status. So what we're going to do, we're going to go ahead and drill down into this tile. So when you drill down into this tile, you won't be able to see the query up top because we're zoomed in a little too much, but you'll be able to see the pod resource that is having issues within the cluster environment. And notice that this is within our managed to live cluster environment. One thing that Jorge mentioned is that when you're accessing the data from search, all the data is going to be brought into a centralized place. So you'll be able to see the resources from the hub cluster along with the managed clusters that you're managing. So from here, we can see that our managed to live cluster for our airline application And one thing I should note is that this airline application is actually deployed across our fleet of clusters, but for this managed cluster, you can see that it's within the crash loop back off state. So one unique feature that Jorge mentioned was actually going into the resource or the pod resource and viewing the logs that are available. So we can drill down into that pod resource. And from the top navigation, you can see the logs link. So if we click on that, we'll see that there's a few issues that are occurring within our container. So we are running a Postgres database image. So right now what we would need, it seems that we have issues with the environment variables that we are setting within the container. So we need the PostgreSQL user, the PostgreSQL password, and the database environment variable set. So let's go ahead and compare that to one of the other airline application resource. So if we were to go, actually, let's take a quick look at, notice how at the top, there's also a few related resources. So search is actually providing these relationships for the resource that you're querying for within the search page. So what we're going to search for is the related deployment for this airline application. So we're going to go ahead and drill down into that. And if we were to scroll down, we're going to take a look at the environment variables that are set for the container. So we can see that we have our PostgreSQL user, our pass, and our database. So we see that we do have them set, but there's still an issue within the environment. So let's go ahead and take a look at one of the airline applications that's actually working. And remember, I said this is being deployed across multiple clusters within our fleet. So I'm going to go ahead and search for the resource based upon the label. And this is the app equal airline app. And this will display all of the resources that are given that label. So what we want to focus on are the pods that are running. So here you can see are the airline app for our managed cluster 1 or man live 1. For our man 2 live cluster, where we show that there's a crash boot back off. And of course, within our hub cluster, you can see that the pod is running. So what I want to go to next is to search for the related deployment. And we're going to focus on the one that's set for the managed 1 live cluster, just to do a quick comparison. So I'll open that up within a separate tab, and I'm going to open the managed 2 live cluster YAML for the deployment. So we can go ahead and see that these are the environment variables that we were looking at before. And we're going to go ahead and compare those to the one that's within our working deployment. So here we can see we have PostgreSQL user, password, and database. So the issue that's occurring here is that we are using the wrong environment variable name. So there will always be an error that's throwing, or that's going to get thrown for that deployment. So let's go ahead and edit this deployment. And we're going to go ahead and save those changes. And we're going to go ahead and scroll back down just to verify that this has been updated. And as you can see that this is updated now. So let's go back to our search page. And we're going to go back and look at the related pods. And as you can see, our managed 2 live cluster pod for the airline application is now running. And just to double check, we can go ahead and look back into the logs, where before we were seeing that there was an environment variable issue, and now we're seeing that the logs are not showing the error. So that is one scenario for our problem determination. And the next scenario that I want to show.
Sorry, want to break. This is almost a marathon. This is actually what you showed is pretty awesome. Let me ask a couple of stupid questions.
Sure.
When you are showing those YAMLs, are those YAMLs being brought? Are they being brought by the search code back to the ACM hub, or are you reaching out live to the managed clusters to get the YAMLs?
Yeah, at that point, we are reaching live. The full YAML is on the managed cluster. Search knows about the location of it, so we go to the managed cluster and bring that like live. So it's definitely the latest version, and we're working against the latest YAML.
Perfect, awesome. This is awesome. And this crash loop back off. I have a series. I have a fleet of clusters, and somewhere on some corner of Earth or several corners of Earth, things are crashing. and we are doing it from one place. We are finding out, okay, not this time you showed a log, but I am assuming in other cases where it might not be in logs, in the YAML, we'll capture the events, right? And we can see, whether it's the image doesn't exist, or maybe my secret is wrong. I mean, Gurney, these are one of the most common things, right? And we can look at this from a central place.
We can look at it from a central place, resolve it and debug from one place without having to find how to log into those clusters, because we have already been authorized to see the clusters.
This is fantastic. And the other stuff is searching by label. So if we are following best kube practices, that means I might have deployed a service in several clusters. I can grep for the label and find out all the installations, that are all the clusters that are running and the related stuff.
Yes, you can. So even this one, let's say you can show that go by the label. I think we have a label with department name. So that will bring down the specific deployments that are marked for that label.
Fantastic.
Yeah,
if you give a department name label, fantastic.
And for those who natively use stuff like Argo CD, OpenShift GitOps, who use, even just deploy operators via some process, all of those artifacts usually have a consistent app name label or some consistent enforced labeling through, for example, rolling it out through Argo. Because we maintain a whole list of OpenShift GitOps applications for RBAC and other configurations on our clusters and policies, and all of those can enforce and replicate those labels. So if you can search by label, you can get an alert that, hey, Argo CD's fired, that one of your applications is in a bad state, and you can go over here and use the label for that name and find those resources related to that application.
Yeah, that's really awesome. Gurney, latching onto your operator stuff, could we actually find out, Disaiah, on what operands an operator creates? We actually look on a custom CR and find it out?
Yes.
Okay.
Yes, we can take a look at our own multi-cluster hub.
There you'll be able to see the related resources to the multi-cluster hub for this cluster environment.
Okay. I guess at this point you might be better off searching for labels. This creates things with those labels. Okay, got it. But anyway,
it depends if you did the labels right. But in this case, let's say if we didn't do labels right, we search for just the multi-cluster hub is what installs our ACM. So we see the CR and we see all the 9 things that it created directly. We'll see if Disaiah expands that. One of it is it shows 7 subscriptions, which that will lay down all the things. So that's a way to kind of learn what the operator did for us.
Yeah, it's interesting, Gurney. I don't know how many times you have faced with this, but when I install something new just to play with, the first thing I do is, okay, what all things does it create? What is the mischief that it's doing? It takes time to understand that, right?
Exactly. And I was going to say the other one is we have 2 clusters that we keep up that are near identical, one for dev and one for dev semi-internal production and one for CI use. So it's kind of more of a dev surfaced. Both of those have almost the same resources deployed on them, but yesterday one of them was unreachable. And this is exactly what, if we had both of these in the same hub, I could say, what is the difference in this component between those 2? Because of course I got an alert about it. So I have Alert Manager set up. So Alert Manager pings me and yelps and says, hey, your cluster's down. But now I want to see what the difference is. And I had 2 terminal windows with 2 different kube configs set, just furiously trying to figure out what was different. And this is one place where I can side-by-side them super easily that would have saved some time. And the other important question is, so you pull up the YAML, you edit it live, it saved and applied back to the managed cluster, and then almost immediately showed you the new status. That is even easier than running CLI commands. That's amazing.
Yeah. Awesome.
And now the next scenario that I want to show you guys is something that Jorge also referenced to earlier, with just in regards to RBAC. So if a user, say for instance, if a department is allowing a user to access one cluster and only wants to see that information for one cluster instead of viewing the resources for, for instance, our managed one live cluster, we can actually restrict them to only see data from the cluster that their role is being assigned to. So we have a user. Let's see if I can. Oops. Technical difficulties, but that's okay. Let's try this.
That's what Gurney wants, by the way, technical difficulties. He really wants that.
Let's try this.
We haven't taken down any resources on AWS in the stream yet, but Joydeep, I'm scheming. We might have to do just a you and me show where we actually do break something.
Break something and then try to repair it live, right?
So just to continue on with the RBAC, so we're signed in as our user 1. And if we wanted to take a quick look back at the resource that this user is verified to look at, let's take a look back at our airline application. So that
Can you zoom in a bit?
Yep.
Thanks, sir.
Okay, that's really user 1. I was not knowing whether you're playing games, Disaiah.
And let's check out the app equal airline app. And as you can see, if we were to view the related pods, the only pod that's displaying is our managed 2 live cluster pod. So before, when we were signed in as the Kube admin, we were able to see the local cluster pods along with the managed 1 live cluster pods. So this is just something that HCM, once RBAC is enabled, search will filter that data based upon the user role, and the data will be returned properly back to the user.
So this opens up that possibility, not just for RBAC boundaries for permissions, but maybe you have, dev, stage, and prod, and you need a developer to be able to see stage and dev, but you don't want them to touch prod. You can give them the same surface that in the same interface that an SRE is going to see to interface. This is really good because you can give someone, I can teach someone how to use what I'm familiar with as, SRE running production thing. And the developer can see what I see and can understand how to make the SRE's job even easier by labeling things properly or that. Debug problems in stage the same way without any chance of them being able to see or touch my precious production.
Right.
You can label it so we can see production but not change it. That's another way that you can do as well.
Wow.
Okay. And talking about interfaces, is there an API as well somewhere which we can use?
Yes, this is based on a GraphQL API. So all you will have to do is expose that route and access the API. The API is protected by the Kube API token, so you will need that. And I actually can show you an example of it.
Can you go ahead and stop sharing?
That's amazing, Disaiah.
Okay, so yeah, I have Postman here. So I can use a GraphQL API. I already exposed the route. It's just very simple OC create route that we have documented on our documents. So it's just one command, and after that, you will need to get the Kubernetes token, which I already set up on this Postman. But from there, you can write your GraphQL queries. So I'll show you an example of pretty much what we were seeing on the UI. I can write this query that will search for pod with the status of crash loop back off, and that won't give me anything because I just fixed that. So I will just focus on the label. Let me delete this criteria. That's a problem. So if I do this, I should get all the pods that have the label department reservation. I can run this query. And I get my list of pod. Here's the airline application. And I run the query. Now I requested the items, and I also requested the relationship, just like we showed in the UI. And the cool thing with GraphQL is that you can decide what you request. So that's the big benefit. So on the query itself, you can decide to just run the query and get the items, or just run the query and get the relationships. We have ways to filter the relationships. Just looking at the results, and then we see the items, and then we see the related deployments for that application. So you can use the API to get the same data that we showed in the UI. You can use it to automate your workflows and do anything you want to do with that data.
So I have a polling bot job that gives me the status of our internal CI cluster fleet every, I think it's 15 minutes, but that is actually hosted across multiple clusters, and I have to have multiple contexts to run an OC get on each cluster. So instead of doing that, I could just point it to the search host and then request it all from that one source, make one request with one boundary of exposure for, one key to rotate if something gets leaked, rather than having a key to 9 different clusters, and get all that data from one place. That is truly wonderful.
Yeah, and by the way, it's interesting actually that you're using GraphQL here. In fact, probably it makes a lot of sense, but this could be a session by itself. Yes, but anyway, so you say you have a route.
It's a very interesting technology. We can the gist of it is that you define what you want, build the query.
Exactly.
And
exactly. And there's a route. It's bearer token protected. And is this API RBAC'd as well? Or not yet?
Not yet. No.
Okay.
It's in the plans, so we can control who can search. Right now, we don't expose the API by default, so you have to take an extra step. So you could do the protection yourself. We don't provide it by default, but it's really easy to add it if you need it to protect it.
Got it.
That makes sense. Yeah, that's wonderful. My next obvious question is, so you've shown us what only strikes me as a huge amount of work in progress, especially with how robust the UI and the API are with GraphQL, and the performance is wild. The two ones are, how do we get here? How long has this project been going? Where can people find this project in the open source space? If someone wants to look at, peep at the code and see how it works, where can we find it?
Yeah, I can talk you through that. But Goni, are you able to share the information that is part of the message that we sent out, or I can share?
Yeah, just let me know what to share.
I think I have my screen up, so it's much more easier. So it's there on the link that we posted. So we got everything in this link up above. It's also there in the message that we posted, where we have documented the current architecture and also the repositories that are part of this entire project. So you are welcome to contribute, make use of it. We have done well-documented installation process and everything. So yeah, that's where you find it. But overall, if you want to go through the architecture of this, right, search is very analogous to what ACM is, right? Like a hub and spoke model. So we have a collector process that runs the collector, which is responsible for picking up all the resources in the managed cluster. And then once we picked up, we use the REST API, and that is running in the hub cluster, right? So the hub host all the indexing process. The managed cluster's job is to just send the data to the hub. So once the hub gets the data, its job is to index it and then store it in a data store. As we just saw that the API, we exposed an API, GraphQL-based API, where the clients can make use of the API and then render it to the UI. They make an extension to the AI processor and whatnot, right? So that's overall flow of things. But if you want to go through the details, then you can go through that too.
Awesome. That is amazing. The other important question is we talked about scale a lot. Jorge teased something about hundreds of clusters. What does the scale look like for search? What you showed us today? How many clusters can I throw at this collector before things start slowing down?
Yeah. So scale, that's a big focus of what we're doing. Like we started back when we first started, the 10 clusters was big for us. Then we grew to 100. We grew to 1,000. Now we're targeting like 2,000 managed clusters, but now it's ever growing. It's not just the amount of managed clusters, it's the amount of data in those managed clusters keep growing with every new release of Kubernetes, every new release of OpenShift. So it's definitely a growing target, and we are trying to get ahead of it. We have done major re-architecture to go to a more performance database and bring things more to the scale that's needed. Next step after 2000 is like have search at the global hub level, which will be hundreds of thousands. So we're preparing to that next step. We're doing well with the current target of the 2000, and it's an ever-growing challenge that we're tackling and working with.
Wow. See, go ahead, Jody.
No, I mean, what I wanted to slip in was, so scale challenge will go on, and alongside scale, are you guys thinking about any additional feature functions that you would like to add?
Sure. Yeah. Besides scale, that will always be there. The other bigger thing that we have is like we currently have the current state of every cluster, but like everything is flowing through our search collectors and search database. So why not keep a history of that? Like that we think that will help a lot the SREs, because most times you have a problem, it's because something changed. And we have visibility into that. We just don't exploit it yet. That's the next thing that we're looking into exploit. Like how do we keep a history of your resources, what changed and when, and we can use our search database to answer questions such as, well, this pod started failing. What of the related resources to it changed recently? So maybe we'll find that a config map recently changed and the pod is picking up a different configuration, and that's causing it to fail. That's something that's not as easy to see just looking at your resources. You need to debug that. You need to go through different things and figure out all the different resources. But since we have that connection, since we know when things change, we can start becoming smarter later. Even adding analytics and stuff that say, well, this pod change started failing around this time. We can go, what else changed around that time, and help you with the actual process of debugging and fixing your problem.
Yeah, I can imagine it's a dream to get an alert that tells you what changed, to not have to search for what changed and say, this is what it was before.
Yeah.
I found it in our GitOps repo of exactly what changed, but to have an alert fire and say, this pod is in a crash loop back off. Its deployment changed 3 minutes ago from this to this. And now the problem isn't what happened and what changed. It's how did it change and how do I fix it? It gets you, one step in.
Correct. Yeah, the problem determination could be done for you, and then you go up about figuring out who changed it, for what reason, and how to revert that.
That is amazing.
Just want to add one more thing, right? So as we are showing this picture, so one of the things that we are exploring is that right now we are only looking at the Kubernetes resources. We are not tapped into the events that are generated by the Kubernetes. So that's something that we are exploring. If we can bring values by watching the events, and then that can help us in terms of our problem determination.
Xavier, do that. That would be awesome. There is gem in a subset of those events that are being generated across the fleet. That would be awesome.
Yeah, one thing. Other sources of data, like Prometheus alerts and all that, we can tap into those. That's kind of all the opportunity we have, tap all
Yeah.
the different sources of data and put everything together in one place that you can search for what you need.
Yeah, and I'm guessing that feedback is more than welcome. I will toss up, we have an email address for reaching out after the show. If anyone sees this and has any ideas, I can pass it on to Jorge and Xavier and Disaiah, because I'm sure they're happy to hear how you might use this. This is incredible. Folks, we're right near time. Does anyone have anything else cool to show off before we wrap things up for this week? Okay, guys, that was an absolutely amazing demo. I'm now in the background trying to pull up my schedule to figure out what we're doing next week. I might have to leave that as a teaser. We have a couple new streams. We have 3 streams in planning. So we know what we're doing next week. Let me find it in this nice schedule. It's the 13th today. Next stream, we should be talking about Microshift. We'll be looping in there with that team, and I feel like that might be an interesting synergy with today's presentation, because as Jorge just said, their target is eventually going to be what seems to be collecting search data from the cell towers that your provider is running. And that's exactly what Microshift is here to do, a lot of those far edge scenarios. So thanks for joining us. As always, folks, we're going to do the intro as the outro, as always. And next week, we'll probably be back with a couple of branding changes and a couple of fun new things to talk about Microshift. Thanks, everyone.
Thank you, guys.